the last problem I have for you in this section, and the last example I have for you, is minimizing area. We did a maximizing volume. Let's minimize some area here. In this one, we have a rectangular page that is contain only 24 square inches of print. The margins at the top and bottom of the page are to be 1.5 inches, and the margins on the left and the right are to be 1 inches. What should the dimensions of the page be so that the least amount of paper is used? Again, we're minimizing area here. We're talking about the area of paper. Let's draw a picture first. So we have a page, and we know that its margins are from the top. So down here, the top, this is 1.5 inches here, and from the bottom up is 1.5 inches. And then we know moving in to the left that it's going to be 1 inch, right? And over here is going to be 1 inch as well. So our paper's got to be some x by y, and in order to find this whole thing here, all right, so this whole page would be like y plus 2. If I'm going here, I'm going to add 1 this direction and 1 here. So it'll be y plus 2 and x plus 3. This is the area that I want to minimize. All right, that's the area I want to minimize. Okay, so we better come up with a secondary equation. Well, what's the stipulation that they put on us when we were reading the problem? The stipulation would be that, let's see, what's it say? A rectangular page is to contain 24 inches of print. Okay, so 24 inches of print. We know we can, our print has to be inside these margins right here, right? We can't have print that's outside of the margins. So it has to have 24 square inches of print. So, which is great how we set this up. This distance here is y, this distance here is x. So our secondary equation is x times y equals 24. Well, that's good because we can solve for either x or we can solve for y and get to one variable and minimize stuff. So let's go ahead. I don't know. I like dealing with x's. Let's solve for y. So y equals 24 over x. And let's substitute that back into our equation. So now we have area equals 24 over x plus 2 times x plus 3. Let's go ahead and FOIL this out and simplify a little bit. 24 over x times x is just 24. 24 over x times 3 is 72 over x plus 72 over x. Okay, 2 times x is 2x. And 2 times 3 is 6, so plus 6. Let's combine like terms. So I have 30 plus 2x plus 72 all over x. All right, so there's my area. So we've now gotten our equation to be just one variable. Now we can minimize. First of all, and I always forget this part, let's look at our domain. What would be a feasible answer? Obviously 0 would make this undefined, so we can't use 0. And we can't have a negative value for x. So we're going to be looking at values that are just bigger than 0. All right, so we just got to be bigger than 0 is all. Okay? I don't think I wrote that yet. So x has to be greater than, and not equal to, just greater than 0. All right, so that's not too big a deal. Well, let's go ahead and let's take the derivative and find our critical points, and then maybe we can minimize, find our minimum. So 30 plus 2x, so let's take the derivative. So with respect to x, so dA dx equals the derivative of 30 is 0. Derivative of 2x would just be 2 plus then what I would do to take this derivative of 72 and bring this up to be x to the negative 1. So I'd bring my negative 1 down and decrease my power by 1, so I'd have a negative 72 x to the negative 2, which would be over x squared right there. Okay, well let's solve for our critical points. Let's set it equals 0 and let's solve. So 0 equals 2. Let's go ahead and make that a minus. plus a minus. Might as well make it a minus. My smartboard is not cooperating with me here. There we go. Let's go ahead and make that a minus. It won't erase for me, so we'll have to go with it. 72 all over x squared. I'd add my 72 over x squared over, and I have 72 over x squared equals 2 over 1. What I could do, I could multiply my x squared over, divide by 2, or you can cross multiply and divide. I have 2x squared equal to 72. X squared equals 36. X equals plus or minus 6. Well, it looks like it kind of like that first equation that I gave you, or that first problem I gave you. We got x equal plus or minus 6. Again, we can't have a negative value for x, so we know our x is going to have to be 6. So our x is going to be 6. And if we wanted to, we could take the second derivative, and we can make sure that that's a minimum. Let's go ahead and take the second derivative. So I'll have, well, the derivative of 2 is 0. So negative 72, x to negative 2. Let's bring down my negative 2, so I'll have a positive 144 x to the negative third power, so 144 over x to the third. If I plug 6 in there, you cube 6 and divide it, you have a positive over a positive. I'm going to get a positive. We know that the second derivative test tells us that if we have a positive number, we're going to have a minimum for our extreme. That's going to be a minimum. So we just confirmed the fact that 6 is a minimum. So we found out that x equals 6. Let's go solve for y. Well, we can go back and plug that in right here where we solved for y already. So y equals 24 over 6. 24 divided by 6 is 4. So our dimensions of our paper, all right, what the printed part needs to be 6 by 4. The entire paper then would be, when I plug 4 into here and 6 in here, would be 9 by 6. So we need a 9 by 6 piece of paper in order to have 24 inches of print with 1.5 margins on the top and 1 margins on the left and the right. So I hope this stuff helped, and we'll see you in class tomorrow.